Surya, and this is my science bio 2. Question. Oxygen transport through myoglobin. So actually, this is a Galton board. This is a ball, and these are all nails. So with the probability that the ball falls in this whole histogram is it's in the center high and it reduces. So it's like a bit of like Gaussian. Okay, this is a bit pictorial thing, and this is just an introduction of myoglobin. So myoglobin is actually base. It's like hemoglobin. Hemoglobin is actually used to transport oxygen through lungs, and myoglobin is actually used to transport oxygen through muscles. So what's the question? Using spherical Galton's model, uh, investigate the transport, the mean displacement and the mean square displacement for a spherical particle representing an oxygen molecule from the surface to the center of the sphere. Each nail of the spherical Galton board can be considered as a point. It is given separation distance. Any two adjacent concentric spheres is a constant, and the distance between any two near neighbor nails on any given concentric sphere is also a constant. Okay. So first, to solve this problem, let's go to a normal 2D random walk. This is the thing. This is the same Galton model which I drew. Assumption. Suppose a ball is dropped from the topmost nail and you can't go either left or right, then let probability go left is equal to A and probability to go right is equal to B. For an unbiased board, A equal to B equal to half. Let the total number of steps be n and n1 be the steps going left and n2 be the steps going right. n1 plus n2 equal to n by intuition. For a ball to hit the center, n1 should be equal to n2 should be equal to n by 2. Since if it starts like this, if it goes left and if it goes right, we have to get the overall, so n1 equal to n2 is equal to n by 2, half distance. Calculation probability distribution. This is the probability that the ball takes n steps to the left and n2 steps to the right. So p is equal to n factorial by n1 factorial dot n2 factorial into a to the power n1 b to the power n2, where a is the probability to go left and b is the probability to go right. This is just by binomial distribution. Now, mean displacement. So actually mean of n1 minus n2 is equal to mean of n1 minus mean of n2. This is by intuition, where n1 is the mean displacement on right and n2 is of left. Now n1 is equal to, this is the formula of mean, like mean is equal to sigma of probability x is equal to xi times x. This is the probability distribution. This is the x random value for the random variable. Using a into dou a to the power n1 by dou a is equal to n1 into a raised to the power n1. Using this one and substituting this equation, we get n1 is equal to this equation. Now, interchanging the order of differentiation summation, like getting the summation inside and differentiation outside, we just get this equation. From that, we using the differentiation rules, we get this one, and overall we get this equation. Now, similarly, we get n2 is equal to b into n into a plus b to the power n minus 1. From equation 1 and 2, n1 minus n2, the whole, like the means subtraction is equal to mod of a minus b times n into a plus b raised to the power n minus 1. We put a mod because we don't know which is greater. So for an unbiased block, a and b are equal to 1 by 2, so we get 0. Thus the mean of a just 2D random on a Galton's board is 0. Now mean square displacement. Let the net displacement be m. M is equal to n1 minus n2. Net displacement square. Net mean square displacement. M square is equal to this equation. Just using a minus b whole square formula, we get this equation. Now finding the first term, that is this one. This is from the intuition which we showed for the mean, which is this one. Just substitute x square. Like n1 square in place of x, you get this equation. Now using n1 square, this equation, you will get n1 square is equal to sigma of n1 equal to 0 up to the upper limit n factorial by n1 factorial into n2 factorial into b raised to the power n2 into a dou by dou a into a dou by dou a of a to the power n1. Interchanging the order of summation and differentiation, we get this equation. Now on solving the equation, we get the final equation like this, like using a plus b equal to 1 and b equal to n minus a. Similarly, we get for n2 square the whole equation like this. Now substituting n1 and n2, these things in the n, what is our mean square displacement, we get the whole equation. Like just substituting the above equations. Now this is the part 2. Part 2 is actually our given question for the spherical Galton model. Assumption: myoglobin can be considered as a concentric sphere consisting of arrays of nails, which is 3D Galton's board. The ball on Galton's board can be assumed to be oxygen at molecule O2. To investigate transport of O2 in myoglobin, spherical Galton's model is suitable. Now, so in spherical model, when the ball is dropped on the surface at the protein sphere, let the axis from the center be z-axis. In spherical model, we assume the ball to be O2 and the axis to be z-axis. The radius of the sphere is just r, and let the O2 molecule take n steps. Therefore, in each step, the ball can go in 4 directions. Like if the ball is thrown like this is z-axis. So it only has at this specific point, it only has this direction, and up direction. Like the face towards me, this direction, and the face away is this direction. So it only has four dimensions or directions in one plane. So let's say left or right on x-axis, front and back on y-axis. Let probability for left be p and right q, and probability for front r. Similarly for back is s. They're all equally probable since it's unbiased. So p equal to q equal to r equal to s equal to 1 by 4. Let n1 be the number of times the ball goes left, and n2 be the number of times it goes right. Similarly n3 the number of times goes front, and n4 the number of times goes back. So by our intuition, n1 plus n2 plus n3 plus n4 equal to n, the total number of steps. Now, for the ball to hit the center of the sphere, which is required, which is asked in the question, n1 equal to n2. Like how much it goes left, it should go the same thing right. These two should be equal, and up and down, front and back should be equal. So n1 equal to n2 and n3 equal to n4. The probability that the ball takes n1 steps, n1 steps left, n2 steps right, n3 front, and n4 back is n1 by n factorial into n2 factorial into n3 factorial into n4 factorial into p to the power n1 dot q to the power n2 dot r to the power n3 dot s to the power n4. Now, this is from the binomial distribution for n random particles. Now, mean displacement. There will be a displacement on two axes, x and y, which are independent to each other. So let the net displacement be d. Displacement on x-axis be L, and displacement on y-axis be m. D is equal to L plus Jm. I am just representing J because L and M are completely independent. Okay, now let's go to the next slide. Average of D is equal to average of L plus Jm, which is equal to individual average of L plus individual average plus M. Now the modulus of D is equal to square root of L square plus M square. Now the mean displacement on x-axis, which is L, is equal to mod of n1 minus n2, which is equal to average of n minus average of n2. Now similarly the mean displacement on y-axis is n3, a mean average of n3 minus mean average of n4. But we know from the previous thing that n1 is equal to this equation by the definition, and by using the property this n1 into p to the power n1 is equal to p into dou p to the power n1 by dou p, we get this equation. Now interchanging the order of summation differentiation, we just put the differentiation out and the summation inside. We approach to this equation mod is equal to this one. So we assumed initially that p equal to q equal to r equal to s equal to 1 by 4. We just substitute in this equation, 1 on substituting in 1. Similarly n2 and n3 and n4 all are equal to n by 4. Now L, which is the average L, is equal to n4 minus n4, which is equal to 0. Similarly M, the displacement on y-axis, is also 0 because my average n3 minus average n4 is equal to n by 4 minus n by 4 is equal to 0. Now finding mean square displacement, assuming net displacement in x-axis to be p and y-axis m. Now L is equal to, like the previous case, L is equal to n1 minus n2 and m is equal to n3 minus n4. Net displacement D is equal to square root of L square plus m square. Now the net mean square displacement is the average of D square, which is equal to L square plus m square whole average, which is equal to average of L square plus average of m square. Now we'll just solve for L square and we can just intuitively get m square. So L square is equal to this one, and we just expand this one. Now n1 n2 equal to 0 because they're equally probable left to go left or right. Similarly n3 and n4 this whole product average equal to 0. Now d square is equal to like I substituted this one and this one in d square. We get L square equal mod of average of L square equal to average of n1 square plus average of n2. So now we just get d square like this, and now n1 square, we are just computing this value, just substitute in the formula of the mean square, and we have to use this equation, and using this one we approach to this equation at last. Now interchanging the order of summation differential, we just change the summation inside and put the differential outside. We get this equation. So now p plus q plus r plus s equal to 1. So we just simplify this above equation like p dot n plus p square dot n square minus p square n. Similarly, we get n2 square, n3 square, n4 square. Now net mean square displacement. We're just adding all this, and we're just taking all the p, q, r s terms common, and r, s, p, q all are 1 by 4, which implies the whole mean square is equal to 3n by 4 plus n square by 4. Thank you. Thank you for watching.